For any two non-empty sets A and B, the Cartesian product of A and B will be equals to the Cartesian product of B and A if and only if A equals to B. Now this is a biconditional statement. So let's try to simplify the statement before we prove that this is a true statement. So this can be converted into two conditional statements, one being if we consider A to be equals to B, then it must be true that the Cartesian product of A and B equals to the Cartesian product of B and A. And the other conditional statement would be if we say that the Cartesian product of A and B equals the Cartesian product of B and A, then it must be true that the two sets A and B are equal to each other. So let's name the two conditional statements as statement number 1 and statement number 2. We're going to prove each of the two statements individually. So let's start with the first one. So in proof number 1, it's given here that we have the two sets A and B that are equals to each other, and we have to show that the Cartesian product of A and B will be equals to the Cartesian product of B and A. Okay, so that means we're going to consider an arbitrary element. So let A comma B be an arbitrary element such that we are going to consider this ordered pair belongs to the Cartesian product of A and B. Now, this simply means that if we consider the first element of the ordered pair, which is A, it's going to belong to the first set, that is A here. And the second element of the ordered pair, which is B, that is going to belong to the second set, which is B in our case. Now, since it is given here that the set A and B are equal, what we can do, we can rewrite this statement as A belonging to the set B. So in place of A, we are using B, and the statement B belonging to the set B can be also expressed as B belonging to A. So here we are using the fact that the set A and set B, these are two equal sets. Now A belonging to B and B belonging to A, that simply tells us that the ordered pair A comma B, this is going to now belong to the Cartesian product of B and A. So we started out by considering an element which is the ordered pair A comma B, and that ordered pair belongs to the set, the Cartesian product of A and B, and we were able to show that the same element also belongs to the Cartesian product of B and A, which means that this simply tells us that our Cartesian product A of A and B, this is going to be a subset of the set, the Cartesian product of B and A. Now we can go the other way around. So here, so let's label this as A, statement number A. Next, what we'll do, we're going to consider another arbitrary element C comma D. So let C comma D be another arbitrary element such that this ordered pair C comma D is a member of the set, the Cartesian product of B and A. This simply tells us that the C is going to belong to the set B and D is going to belong to the set A. Since A equals to B, we can rewrite the statement as C belonging to the set A and C D belonging to the set B. Again, here we have used the fact that A and B are two equal sets. Now, this statement simply tells us that the ordered pair C comma D, this is going to be a member of the set A and the Cartesian product of A and B. So here also we have started out by considering the ordered pair C comma D, which is a member of the Cartesian product of B and A, and we are able to show that it is also a member of the set, which is the Cartesian product of A and B. So this simply tells us that the Cartesian product of B and A, this is also a subset of the set, the Cartesian product of A and B. Now, if we combine statement A and B, we can say that, so from A and B, what do we get? We can say that the Cartesian product of A and B, this is going to be equals to the Cartesian product of B and A. So we have used the definition. So let's quickly state the definition. That means if A is a subset of the set B and B is a subset of the set A, then this simply means that A and B are going to be two equal elements. All the elements of A are in B and all the elements of B are in A. It implies that A equals to the set B. So here we have verified the first statement, the first conditional statement. That means if A and B are two equal sets, then it is always going to be true that the Cartesian product of A and B is going to be equals to the Cartesian product of B and A. Now, moving on to the next conditional statement. We begin by first considering an arbitrary element x which is a member of the set A. Now if x is a member of the set A, then can we not say that x comma b is a member of the set A, the Cartesian product of A and B for all values of B belonging to the set B. If for any values of B that we choose belonging to the set B, x, the ordered pair x comma b is definitely going to belong to the Cartesian product of A and B. Fine. Now this simply means that the ordered pair x comma b is also a member of the set, the Cartesian product of B and A. Now that is true. This is true because it's already given. We have already considered that the Cartesian product of A and B equals the Cartesian product of B and A. Now what does it mean? This simply means that x belongs to the set B and we have B belonging to the set A. So we only need to show that x belongs to the set B. This simply implies that x belongs to the set B. Meaning we started out by considering an element x which is a member of the set A, and we were able to show that it is also a member of the other set B, provided this is a true condition. This simply means that A is going to be a subset of the set B. Fine. So this is one part. The other part will be, we'll consider another element. So let another arbitrary element be y, such that this y is a member of the set B. If y is a member of the set B, then we can say that A comma y is also going to be a member of the set, the Cartesian product of A and B for all values of A belonging to the set A. This simply means that the ordered pair A comma y is going to be a member of the set, the Cartesian product of B and A. This is true because the Cartesian product of B and A is equals to the Cartesian product of A and B. Now from this statement, we can say that A is a member of the set B and y is a member of the set A. But we only need this statement that y is a member of the set A. We started out by considering y belonging to B. We were able to show that y also belongs to A. This simply tells us that B, the set B, is a subset of the set A. Now since A is a subset of B and B is a subset of A, then we can say that A is going to be equals to B. So this is this becomes equal only if we use this condition that the Cartesian product of A and B equals the Cartesian product of B and A. Now since we have shown both of the two conditional statements 1 and 2 are equal, this means that the Cartesian product of A and B is going to be equals to the Cartesian product of B and A if and only if A equals to B. Hence proved.